Just inform Prajwal Gowda to rejoin again because there was some technical problem. Just inform Prajwal Gowda Malgowda to rejoin again. Somebody just inform him. Manjunath Melligeri, Pratmesh Patil, Joslino. Anybody else? Anybody else joined late? Anybody else here?
Sir, rule number 20.
20. Name, please.
Samir Khazi.
Samir Khaji. Okay, I have marked yours. Anybody else? Anybody else? Okay. Are you able to see the screen, students?
Yes, sir.
Okay. In the last class, I was discussing about the hybrid model, and we discussed the advantages of the hybrid model. Okay. In continuation of that, next we will see, we'll come back to the RE model. In the initial classes, we had discussed about RE model of the common emitter fixed bias configuration. Next, we'll continue with the RE model of the transistor in common base configuration. RE model of the transistor in common base configuration. This is how it looks like. Now, this is the common base configuration. Common base configuration. Base is common between the input circuits and the output circuits. You can see here base terminal is common between the input section and the output section, and hence this type of configuration is called as common base configuration. Common base configuration. Right? We will be developing the RE model, that is emit resistance model of the transistor connected in common base configuration. Okay, this is what type of transistor here? Is it NPN or PNP? This is NPN or PNP here? Yes. Is it NPN transistor or PNP transistor?
NPN, sir.
It is the NPN transistor. Okay. If the arrow mark is towards the transistor, then it is PNP. The arrow mark is away from the transistor, then it is NPN transistor. Okay. This is how we will be differentiating NPN and PNP. Fine. Now here we have the emitter terminal, the base terminal, and the collector terminal. Input terminals are emitter and the base. Input terminals are emitter and the base. Right. Output terminals are collector and the base. So it's a 4-terminal device or a 4-terminal circuit. Okay. Now here the input current is the emitter current. Input current is the emitter current. Right. Output current is the collector current. In the common base configuration, input is applied to the emitter terminal. Input current is the emitter current, and the output current is the collector current. And we know that according to our convention, the directions of the arrow mark should be always inwards. That is, they should be pointed into the circuit, into the transistor. That's why we are showing the arrow mark into the transistor here, and also the collector current also we are showing into the transistor. Right. This is a circuit which shows the NPN transistor in common base configuration, which is a 2-port network. As the base terminal is there in both input circuits and output circuits, it is called as common base configuration. Now here we have to observe the directions of the IB and IC currents. If we look into the emitter current direction, it is going away from the transistor. It is going away from the transistor, but convention wise we are taking it inside. Okay, actual current direction of the emitter is, it is going away from the transistor. This is the arrow mark what you are seeing, is it not? It is going away from the transistor. But what about the base current and the collector current? You can see here collector current is moving into the transistor. Similarly, the base current also moves into the transistor. So the sum of base current and collector current is the emitter current. I is equal to IB plus IC. Is it not? Therefore, as the direction of the emitter current is away from the transistor, it is taken as minus. Direction of the emitter current is taken as minus. Therefore, II input current is minus IE, because the direction of the emitter current is away from the transistor. Then the collector current is moving into the transistor. Therefore, it is plus I naught is equal to plus IC. This is how we will be differentiating between the directions of the emitter current, base current, and the collector currents. The NPN transistor IE is out of transistor indicated by the arrow mark on emitter terminal, and IB and IC are into the transistors. Therefore, we take II is equal to minus IE and I naught is equal to IC. II is equal to minus IE and I naught is equal to IC. Here, the emitter base junction is similar to the N junction diode. Emitter base junction is similar to the N junction diode. Is it not? We have studied this when we are studying the transistor circuit next to the diode. Right after the explanation of the diode, next when we were studying the transistor circuits, that time we discussed that the emitter base junction is similar to the forward biased NP, that is forward based diode condition. Okay, so it is similar to the forward based diode condition, that is the N to P junction. Therefore, it can be represented as a diode. Emitter base junction is similar to a PN junction diode. Hence, at the common base transistor, at the input of the common base transistor, it can be represented by a PN junction diode. In this common base configuration, we have in the common emitter configuration. In the common emitter configuration, we consider the current gain as beta. Is it not? Here we are considering the current gain as alpha. In the common base configuration, current gain is represented as alpha, and we know that the current gain is given by the output current divided by the input current. Output current is IC, input current is IE. So alpha is equal to IC by IE. Alpha is equal to IC by IE. That is a normal alpha. That is alpha is given by IC upon IE, or IC is equal to alpha into I. IC is equal to alpha into IE. That means the collector current depends upon the emitter current. Collector current depends upon the emitter current. As emitter current increases, collector current increases. As emitter current decreases, collector current also decreases, because they are directly proportional to each other. IC is directly proportional to emitter current. IC is equal to alpha into IE. As it is directly proportional, collector current IC is controlled by the emitter current IE. Therefore, at the output terminals, at the output side, the common base transistor is represented by a controlled current source. Here, at the output section between the collector to base, it is represented by a controlled current source. We know the meaning of controlled current source. Controlled current source is the one which depends on the input current. Okay, it depends on some other current. So such a current source, we are calling it as a controlled current source. If the voltage depends on some other voltage, then that particular voltage source is called as the controlled voltage source. Right? We have discussed this in our previous classes. Controlled voltage source and the controlled current source. Hence, at the output, common base transistor can be represented by a controlled current source. Now, this current IC current is flowing between the base to collector junctions. Yes or no? Here, the collector current IC, it is flowing between base to collector junctions. Right? Therefore, the controlled current source is placed between the collector to base junctions. The controlled current source, which is a representation of IC is equal to alpha IE, is placed between collector to base, because the collector current is flowing in between the collector to base junctions. Are you following here? Yes. Now, if we look into all these things, what all we discussed just now, so looking into all these considerations, we can draw the RE model of the NPN transistor in common base configuration. RE model of NPN transistor in common base configuration, which is as shown here. As I told, the emitter to base junction, it is similar to the PN junction of the diode. It is similar to a diode. Okay, it is represented by PN junction, a diode. Now here the emitter current direction is, we are having minus here, II is equal to minus IE. Therefore, the diode is represented by a reverse polarity, negative positive. If the input current was positive, then this diode was represented by positive negative. As the input current is negative here, minus IE, therefore the diode is represented in a reverse direction, that is negative positive. Okay, in between the emitter to base terminals. Then we have the controlled current source, which is placed in between the collector to base junctions. It's placed between collector to base junctions. IC is equal to alpha into IE. That is the current gain IC for common base transistor. It is for common base transistor. The collector current IC is given by alpha into IE. This is a controlled current source. What is the output current? Output current is IC. Output current is IC. Okay, so this is how the RE model is drawn for the NPN transistor in common base configuration. Still, this can be modified further. This is the generalized RE model of NPN transistor. This, it can be further modified. Instead of this diode, it can be replaced by its resistance. Okay, because we know that diode has some resistance. When we are applying an AC signal to the diode, right, there is some resistance developed in the diode, and that resistance we are calling it as a AC resistance. AC resistance. So this RAC, or R resistance of the diode, is given by 26 millivolt divided by, right, RAC, that is 26 millivolt divided by ID, or here for a transistor it is given by 26 millivolt divided by IE. 26 millivolt divided by IE. Okay, for a diode it is 26 millivolt by ID, where the ID is the diode current, and the diode current is nothing but the emitter current here. That is for the forward biased diode is similar to the emitter based junction of the transistor. So ID can be replaced by I. This formula we have discussed how it has arrived. Okay, can anybody recollect this? How this formula has arrived? Based on which equation? This formula RE is equal to 26 millivolt by IE. It has come from which formula? Which equation?
Shockley's equation.
Very good, Shockley's equation. So ID is equal to IS into e raised to VD upon eta VT minus 1. That equation. Okay, that is the Shockley's equation, diode Shockley's equation. From that equation, this equation has come into picture. Okay, RE is equal to 26 millivolt by ID we will get for the diode. That we can replace for the transistor. Instead of taking RAC, we can replace it as RE, because it is the emitter resistance for the transistor. That is equal to 26 millivolts by IE. So common base RE equivalent circuit is obtained simply by replacing the diode by the AC resistance RE. Diode is replaced by the AC resistance RE, and this is shown in the next figure. Instead of a diode, it is represented by an emitter resistance RE, emitter resistance RE. Okay, we have the input current, that is minus IE, right? Then the input impedance same, it is ZI between the input terminals, between emitter to base terminals. Then at the output side, we have IC is equal to alpha I, controlled current source. Then output current is IC, I naught is equal to IC. Then output impedance is Z naught. Output impedance is Z naught between collector to base terminals. This is the RE model of the common base transistor. RE model of the common base transistor of a NPN transistor. In particular, it is for the NPN transistor. Are you following here, students? Yes. Are you following here? Yes. Are you following here, Abhay?
Yes, sir.
Abhay,
Understood, sir. Yes, sir.
Understood,
Understood,
no?
sir. Yes, sir.
Understood, Abhay?
Yes, sir.
Okay, fine. Next is RE model of transistor in common base configuration. We are finding out certain performance parameters. We know what are these performance parameters. So whenever we use the word performance parameters, it means their input impedance, its output impedance, its current gain, and its voltage gain. We have to find out these 4 parameters. Performance parameters means the input impedance, output impedance, current gain, and the voltage gain. Input impedance ZI. This input impedance ZI, it is nothing but input voltage by input current. VI divided by II. Input voltage divided by input we have input voltage here and the input current II. Therefore, input voltage by input current gives this impedance Zi between emitter to base terminals. This input impedance for the common base configuration is low and it is in terms of few ohms. Okay. This may be around 50 to around 100 ohms, right? It is the input impedance is less here in for the common base configuration and it is in terms of ohms. Then the output impedance is high. The typical value of output impedance is 1 to 2 mega ohms. Output impedance for the common base configuration is high and it is typical value is 1 to 2 mega ohms. Here we are connecting load resistance. Now this is the circuit without the load resistance. We can see here no load resistance is connected. RL is not connected in this circuit. If we connect load resistance RL in series with this collector to base terminals, okay, in series with this collector to base terminals, if we are connecting the load resistance, then what will be the voltage gain? The voltage gain is given by the output voltage by input voltage, correct? Voltage gain is the ratio of output voltage by input voltage. Therefore, AV, that is voltage gain, is V0 by VI, V0 by VI. V0 is the product of the collector current, it is IC multiplied by the load resistance RL. So the load resistance is coming in series with the collector to base terminal, is coming in series with the collector to base terminal, that is IC into RL, that gives the output voltage. It is a product of current and the resistance according to the Ohm's law. V is equal to I into R. Therefore, V0 is equal to IC into RL. What about VI? VI is equal to II into RE. Input current is II, input resistance is RE. Therefore, II into RE, that gives the input voltage VI, because they are in series, right? We have a single path here. So II into RE, that gives the input voltage VI. Therefore, AV is equal to V0 by VI, that is IC RL divided by IE RE. What is IC? According to the formula, alpha is equal to IC by IE, or IC is equal to alpha times IE. Just now we discussed that formula, current gain formula. Alpha is equal to IC by IE, or IC is equal to alpha into IE. Replace IC by alpha IE RL, this divided by IE RE. IE and IE will cancel, and what will remain here? Alpha RL by RE. Alpha RL by RE will remain. This is the equation for the voltage gain. Therefore, voltage gain is given by the equation alpha RL divided by RE for the common base transistor configuration RE model. Now, as the value of RE is less, right? If we are considering this formula here, RE is equal to 26 millivolt by IE. Millivolt is very less in term with respect to emitter current, correct? Emitter current, if we consider, the value of 26 millivolts is less. Emitter current is slightly higher than this 26 millivolt. Okay. Therefore, the emitter resistance RE is higher because it is inversely proportional to IE. RE is inversely proportional to IE. Therefore, the value of emitter resistance is high. Emitter resistance value is high, right? As the value of RE is high, what about the voltage gain? 1 minute. IE is high, therefore RE will be less. It is inversely proportional. IE is higher, RE will be less. So as RE is less, what about the voltage gain? Voltage gain will be high or low? If RE is less, what about the voltage gain? Whether it will be more or less?
More.
More. It is inversely proportional. As RE is less, AV will be more because it is inversely proportional. Right? Therefore, the value of AV is higher because the value of RE is less. Then RL is connected between output terminals. We know that RL is connected between collector to base in the output section. What about the current gain? Current gain is again the ratio of the output current to input current. Current gain is the ratio of output current to input current. The output current, just look back to the circuit here. Output current is IC, input current II is minus I, right? Output current is IC, but the input current, if we consider the input current that is entering into the circuit, it is minus IE, minus IE. Therefore, the ratio of the output to input current, that is I0 by II, is given by this equation. AI is equal to I0 by I, that is IC by minus IE. IC is alpha IE divided by minus IE. IE and IE will cancel, then minus alpha will remain. Therefore, the value of current gain for the common base transistor RE model is minus alpha. What are the values we are obtaining here? Input impedance Zi is RE, input impedance Zi is RE, output impedance is high, it has a higher value of about 1 to 2 mega ohms. AV it is given by alpha RL by RE, then AI current gain is given by minus alpha, right? These are the 4 values that we are obtaining for the RE model of the transistor connected in common base configuration. Clear here? You all understood here how we are getting these equations here? How we are getting these values? For Zi, Z0, AV and AI. Input impedance, output impedance, voltage gain and current gain. These are the 4 performance parameters of the transistor. Is it clear here, students? Did you all understand here these equations? Any doubts here? Any doubts here in these equations? Yes? Any questions here up till now? Did you follow here, students? Janvi?
Yes, sir.
Okay, fine. Janvi? Janvi? Shubham?
Yes, sir.
Shubham?
Yes, sir.
Followed here, Shubham?
Yes, sir.
Okay. Sankalp? Sankalp?
Yes, sir.
Following here, Sankalp?
Yes, sir. Understood. Yes, sir. Understood.
Okay. Next, we'll move on to RE model of PNP transistor. RE model for the PNP transistor in common base configuration. Just now we have discussed about NPN transistor. Now we are considering PNP transistor. That's the difference, right? It's a PNP transistor. Okay, the arrow mark is pointed towards the transistor, into the transistor. Therefore, it is PNP transistor. For this PNP transistor, the two-port model or the two-port network is like this. Input current is II is equal to IE. Input voltage is VI. It is again the common base configuration only. Base term is common between input sections and the output sections. I0 output current is minus IC. Okay, I0 is minus IC. I will come to that why it is minus IC. This I0 is in between the, or the V0 is in between the collector to base terminals, right? For PNP transistor, IE is into the transistor and IB and IC are out of the transistors. If we look into this, IE is into the transistor, therefore it is positive. I is taken as plus I. Whereas the collector current is moving away from the transistor and hence it is taken as minus. I0 is equal to minus IC. Emitter current it is flowing into the transistor, therefore it is plus IE. The collector current is moving out of the transistor and hence it is taken as minus IC. You can just look into the direction. So it is into IE, whereas base current and collector current will be away from the transistor. Hence, II is taken as plus IE, whereas I0 is taken as minus IC. This is the RE model of the PNP transistor in common base configuration. As we have discussed just now, that the emitter base junction is similar to a PN junction of the diode, Therefore, it is replaced by a PN junction diode. If you look back into the previous model, that is RE model for the NPN transistor, look here, it is minus plus diode polarity, minus plus. So diode polarity, you have to be a little bit careful here about the diode polarity when it is minus plus and when it is plus minus. So as the input current is minus IE here, right? Therefore, this is the diode polarity is represented as minus plus here. Okay, now diode is minus plus diode polarity. Right? If we look into the PNP transistor, the direction is positive, negative. Direction is positive, negative. Okay, because input current is plus I0. Right? But if we come to the output section, I0 is minus IC. Whereas for the previous one, for the NPN transistor, I0 is equal to IC. I0 is equal to plus IC here. Right? I0 is plus IC. Therefore, the current direction is as same as that of the input. That is, it is in the same direction, downward direction only. IC is equal to alpha I. But for this common base configuration in the PNP transistor is the opposite. For the PNP transistor, for the PNP transistor, the output current is minus IC. Therefore, the current is shown upward. It is opposite to the I naught. It is shown in the upward direction. IC is equal to alpha IE. Right? You are clear with this? How we are getting the polarity of the diodes positive, negative, and how we are getting the direction of the IC collector current as in the upward direction. Right? This is II is plus I naught. Therefore, the polarity is taken as the same. That is positive to positive, negative to negative. Then I naught is minus IC. Therefore, the direction of the current is taken as upward. Direction of the current is taken as upward. IC is equal to alpha IE. Same magnitude is same. Only the direction is opposite here, as that of the I naught. Therefore, it is I naught is minus IC. Right? Now, what about the formulas for the NP transistor? We have already derived the formulas for the performance parameters of NPN transistor. What about the performance parameters of the PNP transistor? If we look into this circuit, what is the input impedance? What is the input impedance given here? So input impedance is again VI by II, that is ZI. Okay, ZI is VI by I, input voltage by input current, that is the input impedance. Yes, that is the same. That is nothing but again, if we replace this diode by the emitter resistance, it will be RE only. It is same. Right? That is input impedance formula we got same as that for the NPN transistor. Now, what about the output impedance? Output impedance is also same. It is high. Input impedance is less. Output impedance is high. Then the out voltage gain formula. Voltage gain. V naught is equal to V naught is I naught. That is IC into RE. If you are connecting, if you are connecting the load resistance here, RL, in series between the collector to base terminal, if we are connecting a load resistance, RL, right, in series here with this collector to base terminal, therefore, V naught will be IC into RL, that divided by input voltage. Input voltage is II into RE, input current multiplied by input resistance. Right? So what we get here, IC into RL divided by II into RE. IC into RL, that divided by II into RE. This is same as that of the previous equation. Just look back here, what we have written, voltage gain equation for NPN transistor, IC into RL divided by IE into RE, or II into RE. This same equation. If we simplify this, again we are getting the same thing, alpha RL by RE. Because IC is alpha times IE, just substitute that, then you will get I and IE cancels. Therefore, what remains here, alpha RL by RE. It is same as that what we are getting for the NPN transistor. Therefore, voltage gain equation is also same. What about the current gain equation? Let us check the current gain equation. Current gain equation is given by output current by input current. Output current is IC. Okay, it is minus IC divided by input current is IE or IE. Therefore, current gain is alpha is equal to current gain alpha is equal to IC minus IC by IE, minus IC by II or minus IC by IE. Right? IC is equal to alpha I. It is same as that what we are getting for the NPN again. Just here, there it was input current minus I. Here we are getting output current as minus I. That is the only difference. For the NPN transistor, we got input current as minus I. Input current as minus I because of the arrowhead of the NPN transistor. Right? As the arrowhead is pointing inwards for the PNP transistor, we are getting the output current direction as minus for the PNP transistor. That is, IC will be equal to minus I. IC will be equal to minus I here. Therefore, minus I means minus IC means it is I naught is minus IC, that is minus alpha IE by IE. I and I will cancel, again it will be minus alpha only. Therefore, the current gain equation for the which transistor we are studying here, PNP transistor, is also same as that of the NPN transistor. The basic equations remain the same, and also the final equations of the both NPN and PNP transistor of the RE model remains the same. So what is the conclusion here? The conclusion is AC analysis of transistor amplifier is independent of the type of transistor. The AC analysis for the transistor is independent of whether you are using a PNP transistor or a NPN transistor, because the equations remain the same both for NPN and PNP transistors. Right? This is the conclusion that we are drawing from the RE model of the PNP transistor in common base configuration. What is the conclusion? The AC analysis of transistor amplifier is independent of the type of transistor, whether NPN or PNP used in the circuit. Let us solve an example. Up till here it is clear, students? Up till here it is clear? Sanket? Any doubts up till here? Sanket? Sanket, any doubts up till here?
No, sir.
Okay. Let us solve an example here. Note down this example. Your calculus, note down this example in your notebooks. For the common base configuration, of figure below, next you can see the figure. Note down the statement first. For the common base configuration of figure below, I is equal to 4 milliampere, alpha is equal to 0.991, alpha is equal to 0.991, an AC signal of 3 millivolt is applied. An AC signal of 3 millivolt is applied between the base and emitter terminals. An AC signal of 3 millivolt is applied between the base and emitter terminals. If RL is equal to 610 ohm, calculate. If RL equal to 610 ohm, calculate. First one, RE and ZI. A, RE and ZI. B, second one, AV and AI. C, V0, II and I0. V0, II and I0. D, fourth one, Z0 with R0 equal to infinity and IC, IE and IB. The statement is, for the common base configuration of figure below, I is equal to 4 milliampere, alpha is equal to 0.991, an AC signal of 3 millivolt is applied between the base and emitter terminals. If RL equal to 610 ohm, calculate. First one, RE and ZI. Second, AV and AI, that is voltage gain and current gain. Third, output voltage V0, input current II, output current I0. Fourth one, Z0, that is output impedance with R0 equal to infinity, and collector current IC, emitter current IE, and base current IB. So if you have noted down the statement, just note down the circuit here. This is the circuit that is given to solve the example. It is a NPN transistor that they have given. Even if they give the PNP transistor also, you have to use the same equations. Remember, even if they give the PNP transistor also, you have to use the same equations. Quickly note down the figure here. Did you note on the statement and the circuit here? Suraya Banu? Suraya Banu? Did you note down the circuit and the statement, Suraya Banu? Okay. Let us solve this example. What is the first one they have asked? So what is the statement? Just read the statement before solving the problem. Write down the given data first and then start solving the example. This is the approach that you have to follow for any problem, right? Whenever you are solving any problem, the approach should be first read the statement, try to understand it, okay? See whether what values they have given, okay? Just try to analyze it, right? And then write down the given data first, and then start solving the problem, then start solving the example, okay? First, try to understand what it is. For the common base configuration of figure below, they given this figure. This is the common base configuration, and they are using NPN transistor, right? Fine. I is equal to 4 milliampere. They are given the input current IE. IE, that is input current is given. IE is 4 milliampere. Alpha is 0.991. Alpha current gain for common base configuration. It is 0.991. AC signal of 3 millivolt is applied. They have given VI. VI is given. VI is 3 millivolt. Input voltage. VI is 3 millivolt. Applied between base and emitter terminals if RL equal to 610 ohms. RL resistance which is connected at the output side. RL load resistance, right? It is 610 ohms. Calculate RE. First one they asked RE. Use the formula RE is equal to 26 millivolt by IE. RE is equal to 26 millivolt by I. Okay. Calculate here how much you are getting the value of RE. Take your calcium and calculate all of you. RE is equal to 26 millivolt by IE. Formula is RE is equal to 26 millivolt by I. Find out the value of RE. How much you are getting? RE value. Emit resistance. RE. Yes, please. RE, how much you are getting?
6.5, sir.
6.5 ohms, exactly. RE is 6.5 ohms. That is ZI is nothing but RE here. The common base configuration. ZI is equal to RE, that is equal to 6.5 ohms. 6.5 ohms. Okay. Then next, what they have asked, ZI they have asked, so ZI is 6.5 ohms. Okay, ZI is 6.5 ohms. RE, that is nothing but ZI, it is 6.5 ohms. Next, they have asked AV, voltage gain. Let us add the equation for voltage gain. Voltage gain is given by alpha RL by RE. Okay, equation for voltage gain is direct formula is available. AV is equal to alpha RL by RE. You have to remember this formula, memorize it. For common base configuration, RE model, right? AV is given by alpha RL by RE, both for NPN and PNP transistors. Alpha RL by RE. Then substitute to the values here. Alpha is given. Alpha is how much? 0.991. RL is 610 ohm. RE just now we have calculated 6.5 ohms. And find out the value of EV. EV is equal to alpha RL by RE. EV is equal to alpha RL by RE. Find out the value here, students. What is the value of AV?
Sir, 93.
93. Right? Anybody
93,
getting
sir.
different answer? Anybody getting different answer? Okay. 93 is correct. AV voltage gain is 93. Next, what about the current gain? What is the formula for current gain? AI. AI formula is what? Yes, please. Anybody? Formula for current gain is what?
VI by ZI.
VI by direct formula is available. AI, what you are saying? VI by ZI. No, current gain. I'm asking about current gain. AI, not the input current. Input current,
Minus
if they
alpha.
ask, that is VI by ZI. You're right. Okay. Now, what I'm asking is current gain, AI. You have to be little bit, you have to understand the things and then you have to do them. Okay. So, they're asking the current gain. AI, they are asking. What is the equation for current gain we are having? AI is how much? Equation for current
Minus
gain? Here, AI is equal to minus alpha. We already derived that equation. AI is equal to minus alpha, right? Minus alpha. Use that directly. AI is minus alpha. If you use AI as minus alpha, that is alpha is given. It is 0.991. Given in the statement. This AI current gain will be minus alpha, that is 0. Minus 0.991. We calculated the value of current gain. Next, third part of the problem. What they have asked next? Not output voltage they have asked. Output voltage. How to calculate the output voltage? Output voltage, how to calculate? Yes, here we know the equation for voltage gain, right? Voltage gain is output voltage by input voltage, basic fundamentals. This voltage gain is output voltage by input voltage. That is the voltage gain. Current gain is output current by input current. Voltage gain is output voltage by input voltage. Therefore, what will be the output voltage? If AV is the voltage gain, it is V naught by VI. AV is V naught by VI. Therefore, V naught will be equal to AV into VI. Correct? Output voltage V naught will be equal to AV into VI. Yes or no? Voltage gain AV is V naught divided by VI. Just here what formula we have used here while deriving the equation for voltage gain. AV is V naught by VI. Correct? That only we have to use. Therefore, V naught will be equal to AV into VI, cross multiply. AV is V naught by VI, or V naught is equal to AV into VI. We got the value of AV. Just now we have obtained that. Input voltage is given. Therefore, multiply these two, you'll get the value of V naught. Just do that and tell me the answer, students. How much you are getting? V naught. V naught is AV into VI.
279 millivolts.
279 millivolts, exactly. 279 millivolts. Right. Similarly, find out current, input current, II. Just now you told the formula. II is equal to VI by ZI. Right? Because we know that ZI is equal to VI by II, or II is equal to VI by ZI. Just rearrange the terms there. II is equal to VI by ZI. VI is given. ZI also we have
4.6,
calculated.
sir.
Substitute. Yes, please.
4.6.
Just see, check it. Not be no. What is the unit you are getting? 4.6. Tell me in terms of microampere. Keep your calcium engineering mode. Whatever final answer you are getting, keep it in engineering mode. You'll get it in terms of various units: milliampere, microampere, nanoampere. How much you are getting in terms of microampere? Yes.
461 microamperes.
Very good. 461.52 microampere. Just here we are calculating. II is VI by ZI. II is VI by ZI. That is, the input voltage is given. They have given it as 3 millivolt. VI is given. That is 3 millivolt divided by ZI. ZI we have calculated. ZI we have calculated. That is 6.5 ohms. RE is 6.5 ohms. Is it not? ZI is nothing but RE. That is 26 millivolt by IE. That we have already calculated. Correct? Therefore, 3 millivolt divided by 6.5 ohms. That comes out to 461.52 microampere. Okay. After calculating the input current, how to calculate the output current? How to calculate the output current here? Any formula is there? Calculate the output current. Just think. What is the equation for current gain? Current gain equation?
I naught by II.
I naught by I. Exactly. I naught by I. Therefore, I naught will be equal to how much? AI into II. Correct? Current gain AI is I naught by II. Yes or no? Current gain is nothing but ratio of output current to input current. Just look back into this formula, what we have used while deriving the formulas. Here, AI is equal to I naught by II. AI is equal to I naught by II, or I naught is equal to AI into II. I naught is equal to AI into II. AI have we calculated? Yes, we have calculated AI. That is minus alpha. We already got that value. What about II? II also just now we calculated. That is 461.52 microampere. Substitute them and find out the value of I naught. Do that. AI is I naught by II. Just here, AI is I naught by II. Okay, or I naught is equal to AI into II. AI is I naught by II, or I naught is equal to AI into II. Cross multiplication here. Are you following here? AI is I naught by II. AI current gain is output current to input current. Therefore, I naught will be equal to AI into I, cross multiplication. To get the value of I naught. I naught is AI into II. AI into II. Calculate the value of I naught here. How much you are getting? Tejas, calculate that. Tejas. Ratan, Girje. Ratan. Did you calculate that, Ratan? Chandrasekhar.
Sir,
Yes, sir,
minus
doing.
457.36 microampere.
Minus 457 point.
36
Whether it is nanoampere or microampere.
microamperes.
Microampere. Very good. Fine. It is I naught is equal to minus 457.36 microampere. Just here how we are getting that. I naught is the product of current gain and the input current. AI is I naught by II, or I naught is equal to AI into II. That is minus 0.991 into 461.52 microampere. That will be minus 457.36 microampere. That is the value of output current. Fine. Last part of the problem, they have given the condition Z naught is equal to infinity. Just look back into the question. Z naught with R naught equal to infinity. If Z naught is R naught with infinity, then find out the values of collector current, emitter current, and base current. They have already given the value of Z naught as infinity. Z naught is equal to R naught is equal to infinity. Therefore, for the NPN transistor, what transistor is being given here? NPN transistor. II is equal to minus IE, right? It is minus IE. Okay, base current and collector current are positive. Only the emitter current is minus, right? But when finding out the base current and the collector current, we are neglecting the signs here. Okay, because they lead to certain confusion. We are neglecting the signs. Finally, ultimately, answer remains the same, right? When we consider the signs of all the emitter current, base current, and collector current, to avoid the confusion, what we are doing is we are neglecting the signs of these currents. Okay, minus sign, whatever is there, that we are neglecting here. By neglecting those signs, II is equal to minus I and I naught is equal to IC. II is minus IE, I naught is IC. Yes or no? We are neglecting the sign here of the input current as minus IE, and we are simply considering it as IE. Then the formula of IE is given by anybody? IE is equal to IB plus IC. IE is equal to IB plus IC. We know IE, we have calculated the value of input current, that is IE. II is nothing but our emitter current. Am I right? II is nothing but emitter current, that is 461.52 microampere. 461.52 microampere. Then I naught is nothing but IC, that is minus 457.36 microampere. Okay. So that neglect the signs here. So II is for input current, emitter current is 461.52 microampere. I naught is 457.36 microampere. Consider only the magnitudes here. Therefore, I is equal to IB plus IC, or IB is equal to IE minus IC. Neglect the signs, whatever we are getting, just consider only the magnitudes. IE is equal to IB plus IC, or IB is equal to IE minus IC. What is IE we are getting? 461.52 microampere. Collector current is 457.36 microampere. Then subtract these two, IE minus IC. That gives the base current. It is 4.16 microampere. Right? Like this, the value of the base current, right, it is less as compared to that of the emitter current and the collector current. That we can see from this particular equation. The base current value is just 4.16 microampere, whereas the emitter current is 460 microampere, collector current is 457 microampere. Hence, we can conclude here that the base current value is less as compared to the emitter current and collector current. Like this, you can cross verify your answers, right? So cross verification is also important. Whatever values we are getting, we have to cross verify the answers, so that whatever calculations we have made, to check that whether it is correct or not. Right? Here the base current value is less as compared to emitter current and collector current. That means it is correct. Okay, whatever calculations we have made is correct. Right? Did you all understand this problem, students? This example is clear here. Yes, please. Ankita. Ankita.
Yes, sir.
Is it understood here?
Yes, sir.
Clear with the today's topics, whatever we covered in today's class?
Yes, sir.
Any questions here?
No,
Ankita?
sir. No question.
Huh? If you have any questions, any doubts, anything not understood,
Understood, sir.
can ask. Understood? Okay. Prajwal Gowda? Prajwal Gowda?
Yes, sir.
Is it understood?
Yes, sir.
Okay. Ramesh? Vadvadigi? Ramesh? Shiraj?
Yes, sir.
Shiraj?
Yes, sir.
Understood today's topics?
Yes, sir.
Any problem in understanding, Shiraj?
If there is anything, sir, I will ask you.
Okay, just message me or you can call me. Okay,
Okay, sir.
anyways. Okay, fine. Suraya Banu? Suraya Banu? Is it clear here? Today's topics? Suraya Banu?
Yes, sir.
Okay. Okay, in the next class, we'll continue with the RE model of transistor in common emitter configuration. We'll take up that in the next class, right? So in today's class, we discussed about the common base configuration RE model, right? Then for the NPN transistor, for PNP transistor, and then we have solved an example on the RE model of the common base transistor configuration, right? That's all for the today's class. We'll continue in the next class. Thank you.